Second was the gas for coal. So let me say a few words about that, again from our study. I won't spend a lot of time on this, but basically the left-hand panel is our supply cost curve for natural gas in the United States. There's a lot of gas. But on the right side of more interest, I think for this purpose, is to take the median or the mean cost curve on the left and decompose it into different sources of gas. And of course, the big news here, we all know it's big news, this is a quantitative statement of it. The big news is at the low prices, the low break-even prices, like $4, the shale gas is huge. I mean, that's the real message. It's at the lower ends of the cost curve, the shale gas has an enormous supplement, in fact, it's even larger than what remains in the conventional gas production for the United States, which of course is a rather mature gas-producing country. So with that background and this what Dan Yergin calls the shale gale, let's look at this issue of substitution. Can we really make that gas for coal substitution, particularly in the obvious condition of not having a carbon policy in this country, or at least a pricing policy? We'll put aside what EPA is doing at the moment. So here what you find is a picture just to kind of guide your eye. What it shows is the following. In every state, the left-hand bar is proportional to the kilowatt hours produced by coal in that state, divided into efficient and inefficient coal plants, arbitrarily defined as a break at a heat rate of 10,000. So a heat rate above 10,000 is the purple bar, the inefficient plants, and the green are heat rates below 10,000. The right-hand bar is a fiction. It is the amount of kilowatt hours you could produce in that state if you ran the NGCC plants up to 85% capacity factor. As you probably know, the average capacity factor today is just over 40%. So we have a lot of unused gas capacity. That's the message. And the right-hand bar tells you what you could do in that virtual world. The message, obviously, is there are many parts of the country where there is a tremendous amount of substitution available without even any significant capital investment. That's really the message. In fact, when we then run a more detailed model with transmission constraints, et cetera, for ERCOT, since ERCOT is its own country, this is the dispatch curve that we get, and I'll just say that the conclusion is that tomorrow, if you decided to redispatch NGCC ahead of the inefficient coal plants, you could have a 22% reduction of CO2 in the power sector in ERCOT tomorrow. In our full report coming out, you'll find that the number is almost that large for the country as a whole, and the cost of doing so would be equivalent to the order of a $16 a ton CO2 emission price. So pretty low. So it gives you an idea that now in this country already we're going to see some coal plants going out. Well, some have gone out, and particularly if the mercury rule, the EPA, goes through, we expect the order of a 30% reduction in this decade, and that would even put us ahead of that CO2 reduction trajectory without a carbon policy, giving us a little time, hopefully, to develop that carbon policy. Finally, in this, using the recent EIA ARI report, now looking globally, this shows for a variety of countries technically recoverable shale reserves, and below it, the 2009 consumption in those countries. And obviously what one sees is that there is, at least nominally, an enormous potential which would be a game changer on the global geopolitics of gas. And by the way, we would endorse U.S. support for in fact, having a freely functioning global gas market, which we don't have today, but we believe that would be in our security interests, and there's a lot of potential here from unconventionals to affect that. Okay, let me now turn to the third part, which is the zero carbon alternatives, and say a little bit, well, given the time, I may skip some of these, but I was going to say something about nuclear, CCS, and solar, but maybe we'll save some of those for the questions. Anyway, this is a table from our 2009 report looking at levelized costs for new build nuclear, coal, and gas. The only thing I want to say here is that the base case shows that nuclear is on the high side, but there are two factors that could dramatically influence that. One is even a modest cost on CO2 emissions, like $25 a ton, changes the game quite substantially. And secondly, the last column is the reduction from 8.4 to 6.6 cents that one would have if the risk financing premium that we include in our base case were eliminated. In some sense, that is the purpose of the loan guarantee program, which has not really gotten off the ground very, very aggressively, shall we say. But it is to demonstrate the construction, presumably on budget and on schedule, of new nuclear plants, which would then at least work down this risk premium. So these are very, very important. However, we also have, obviously, the Fukushima situation, and while unresolved, I think it is fairly clear that there are some pretty good bets that costs will go up, maybe only modestly, maybe it's a minor change in how spent fuel is managed, maybe dramatically with substantially changed design basis accidents. We don't know, but directionally, costs will go up. Life extension of existing plants, I would say, despite the statements of the NRC to date, clearly will get more scrutiny, and if that results in not having a substantial number of life extensions, I remind you, at least we in all of our projections, we've already baked in all the life extensions, and if they don't happen, we've got tens of thousands of megawatts to worry about. Maybe new passively safe nuclear, which is what we priced on that previous slide, is part of that. That'll be an interesting discussion. We also expect that spent nuclear fuel will be managed differently. What we would like to see is that this gets us off the dime and moves us towards moving fuel to consolidated storage. Finally, the R&D focus will shift from pie-in-the-sky fuel cycles to better operation of LWRs and of waste management. I'll skip that. Well, I'll just say that, again, a DOE hub, MIT is a partner in an Oak Ridge-led hub, developing brand new simulation tools for complex engineered systems. This is a game changer in many dimensions, including in nuclear, and including looking at what I believe will be the new priorities for looking hard at the safety and operation of light water reactors. But again, the hubs are in the middle of it. And finally, I'm not picking a winner here, but I'll just note that the small modular reactors may be very interesting in this context. For those of you not familiar with it, the idea is to go to abandon the gigawatt to 1.6 gigawatt scale, instead go down to somewhere maybe in the 50 to 300 megawatt scale, with the idea that one can overcome the loss of economy of large scale by the economy of manufacturing. The idea is you manufacture these in a factory, on a full humming factory line, with all the benefits that has for learning and cost reduction. Very interesting concept. We don't know if it'll work. If it'll work on the economics, but it's an example of where we have to go forward, in my view, as the 2012 administration budget request did start on the pathway of demonstrating particularly the light water reactor-based small modular reactors. But I will note there is a policy conundrum, in my view, that has not been addressed, and that is that this is not a case where, like with the loan guarantees, you can go in and support one of those designs and one of those designs and one of those designs. And there are about 10 designs competing right now. Because the whole cost proposition is the ability to get a full manufacturing line. We don't need one of these and one of these, we need 15 of those. That is a conundrum for certainly government support moving forward with this. But this is an example, I think, of a very important technology policy intersection that we have to figure out. I'm going to try to end pretty soon. So let me say a little bit about CO2 and geological sequestration. Clearly, we still need an extensive, frankly, we basically have not gotten off the dime in this country in terms of really demonstrating sequestration, which obviously can be a huge game changer given our coal resources and our coal politics. So we really we have to get on with the issue of sequestration with many megatons per site, and we have to get moving. I will just say that, and there was a report also posted yesterday at MIT from a symposium on the issue of looking at CO2 enhanced oil recovery as the pathway to finally getting the sequestration issues addressed. Not well known. We are already using 65 megatons a year of CO2 for enhanced oil recovery. That's like 10 gigawatts worth of coal plant. Of course, it's almost all natural sources. Those sources are getting expensive. We can work down the cost of CCS for the demonstration phase by specifically coupling it to a design for a CO2 enhanced oil recovery strategy, and that is something, again, that we think could change the game in terms of moving forward. I should say this was a joint MIT, UT Austin effort.